Behavioural economics on a post-it number 4. What we're going to consider in this short video is the way in which people appear to psychologically value outcomes. So if you remember behavioural economics on a post-it number 3, we focused upon subjective probabilities. In this video, behavioural economics on a post-it number 4, we're going to consider the value function. So this is how people psychologically appear to value outcomes. If you think about it, risky decisions involve a combination of probabilities and an outcome, don't they? So a risky decision, say for example a 50% chance of winning £10, otherwise you'd win nothing, involves the probability 50% and the outcome winning £10, right? So we're going to consider the way in which people appear to often psychologically value outcomes. So people often appear to have some kind of reference point, which I've indicated here, a reference point at, say, the origin. And anything better than a reference point, anything greater than a reference point, might be considered to be a gain, right? You've gained something away from your reference point. The reference point could be your status quo, the position that you're in now, or it could be what you aspire to. It can vary across individuals, and it can vary within individuals across time. But the point at which you are currently at a reference point, any improvement upon that may be considered to be a gain. And any move away detrimentally from the reference point could be considered to be a loss, right? A loss from where you are now. So if we just focus upon what's called the domain of gains here, if we look at the vertical axis, this is, say, the value or the utility that people might get from a particular gain away from the reference point, right? So if we consider money to be our unit of gain here, right? What this declining marginal increase in the curve suggests is that people are increasingly insensitive to increasing gains, right? So if you had not much money at all and you were to gain £100, you would attach quite a big value or utility to that £100, right? If you were quite wealthy, say you were up here somewhere, you already had quite a lot of money, an additional £100 wouldn't give you so much of an increase in value over and above from where you currently are, right? So it suggests that the richer that you get, the more that you have, any incremental increase in a particular unit would give you a lower increase in value or utility for that unit, right? So you have increasingly insensitive. There's a decline in sensitivity to increasing gains, right? Now I won't explain it in this post-it here, but we call that a concave value function or a concave utility curve. It looks a bit like you're walking into a cave, right? Concave. What this implies is that people will dislike risk. They'll be risk averse in the domain of gains if we're only considering outcomes. Remember, we're not considering probabilities in this particular post-it. We're only considering outcomes. It implies that people will be risk averse when faced with the possibility of gaining something, money in this instance. If we look at just the domain of losses here, we're moving away negatively from the reference point we're moving away negatively from the reference point in terms of the fact that we're losing money on the horizontal axes, and therefore we'll have negative value or negative utility for those losses, right? This also implies that people will have a decline in marginal sensitivity, i.e. in this case, a decline in marginal sensitivity to increasing losses, right? So if you were at this position very close to the reference point and you were to lose £100, say, you might feel quite a big sense of loss. quite a large utility, disutility, or quite a large negative value for losing that £100. But if you had already lost a large amount of money, say you've already lost £100,000, losing an extra £100, so you would be just here, this would be your negative utility or negative value from losing £100,000. Losing an extra £100 would give you only a small further increase in disutility, right? So you have a decline in marginal sensitivity to mounting losses, right? And what this concave utility function in the domain of losses implies is that you will be risk-seeking in the domain of losses, that you would like to take risks if you're faced with losses. That's what that implies. Now, another feature that doesn't really come very strongly in my drawing here is the concept of what's called loss aversion. And this is that people are more sensitive to losses than they are to gains of the same magnitude. So say, for example, if you were at the reference point and you were to gain £100, or if you were at the reference point and you were to lose £100, then losing that £100 would give you much greater disutility. The magnitude would be much greater than the utility that you would gain from winning £100 or gaining £100. People are more sensitive, it seems, to losses than they are to gains of the same magnitude. And that's not picked up in standard economic theory, hardly at all. Right? Certainly not to the extent that it's been observed in the empirical literature. And that's called loss aversion. And if you think about it, if that does hold up, that can be a potentially very useful tool in public policy. You could potentially motivate behaviour change, if you wish to, far more with the threat of losses than you could do with the promise of gains of the same magnitude. Right? Now, what I've talked about in both behavioural economics on a post-it number 3, which was around the probability function, and behavioural economics on a post-it number 4, this one on the value function, those combined are probably the two main modifications that a theory called prospect theory makes to standard economic theory. And prospect theory is the main descriptive theory. It's the main theory of how people do behave that's ever been developed in the behavioural economics field. And for that reason, I'm going to devote an entire post-it note, behavioural economics on a post-it number 5, to summarise prospect theory.